Hey guys, I've been meaning to make this video for a long time on packet capture, packet sniffing, and using a wireshark as a protocol analyzer. I just haven't gotten around to it until now, and the reason I finally got to it was because I set up my new firewall recently and it supports VPN. And being the kind of skeptic that I am, once I set up something like a VPN, I always like to look at the actual packets to confirm that it's really doing what it says on the tin. In this case, I want to make sure that I can establish a secure encrypted connection back to my firewall and tunnel traffic through it so that when I'm sending traffic to my machines at home, it's getting through the firewall using an encrypted tunnel. So of course, all the documentation says if you set it up in this way, then it'll encrypt everything for you. But I always like to actually see it and make sure that it's actually doing what I want, that it's actually encrypting things, that the authentication is not being sent in the clear, that kind of thing. So I recently went to my local coffee shop and sat down, connected to their Wi-Fi, and ran a tool called tcpdump to capture some packets, and wireshark to look at the packets to confirm that I was looking at the Wi-Fi traffic. Then I connected to the VPN and did it again, and captured some traffic again. So this video will demonstrate that. Now the tools that I'm going to show, the easiest one to use is called Wireshark. But I don't recommend that you run that as root. You have to be root or admin in order to capture packets usually. And you can do that. There are features that let you come in here and tell it to capture if you're running as root. But Wireshark is a much more complicated program than tcpdump, so there is a chance that it could have some security holes. So I always recommend that people use something really, really simple to capture the packets, like tcpdump or Snoop if you're on an old Sun workstation, and then use Wireshark to look at those capture files, to look at the packets and decode them. And that way you can run tcpdump as root, but run Wireshark as your own user, not as root. And that sort of mitigates what sort of bad things could happen if you opened up a packet capture file that had some malformed packets that might trigger a security hole or something. So, let's get started. All right. So here we are on the Wi-Fi at the coffee shop. You can see that I have a wireless interface connected. There's my IP address. And I'm going to start up the sniffer. I'm going to run tcpdump-s0, which means save the entire packet for every packet it gets. I'm going to write it to wifi.pcap, and I'm going to tell it which interface I want to listen on. In this case, the wireless interface. And it's running, so now we'll just do something simple. We'll do a DNS query. Now this one should not resolve because this is a host name inside my network. The outside world can't resolve. Yep, doesn't resolve. And so now we'll start up the VPN connection, and I'm going to cut out the bit where I enter in my password. And we just connected. So now we have a VPN tunnel. You can see that I have a new interface, that TUN0, that's the VPN connection back to my private network. So now we're going to start up the tcpdump packet capture again. I'm going to use a different file name since now I'm capturing packets while on the VPN tunnel. And I'm still capturing it from the Wi-Fi interface, not the tunnel interface. So in other words, we're looking at what's going out the Wi-Fi interface. This should be all encrypted traffic if it's something going to my network. So we'll do the DNS query again. this time it resolves. That's good. So the VPN tunnel is working. We'll have to see if it's encrypted or not. And here we're capturing again, this time to using the tunnel interface. Now I want to see the traffic that's going over the VPN tunnel. So we'll do our DNS query again. This time we'll be able to decrypt. We'll be able to see these packets because they're not encrypted. They're going over the VPN tunnel. They're encrypted when they go over the Wi-Fi, but they're not when they go over the VPN tunnel. So here you can see I'm connecting to a mail server and disconnecting. And that's an IMAP server. So let's take a look at some of these. All right, so let's look at the first of these packet captures. I'm going to open it with Wireshark this time. And Wireshark, the Wireshark window is broken into 3 sections. This one shows you the packets. This one shows you some details about the packets, and this one shows you the raw hexadecimal data that makes up the packet. So as I scroll down through here, you'll see these sections are changing based on which packet I have selected. So for instance, here's one you can see is a DNS query. And then in this section, you can expand these. So any part of the packet. So you can see here's the layer 2 part of the header, here's the layer 3 part of the header, the IP part of the header. Here's a part for because it's a UDP packet, here's the UDP part of the header. It gives you those ports. And then this is the DNS query. So you can expand that and see that it's a query, and expand that and see what they were querying for, etc. You could expand all of these and as you wanted, whatever you were looking for. But in our case, this was, if you remember, this packet capture was done using the wireless interface before I had connected to the VPN. So what I wanted to look at was my OpenVPN connection to make sure that when it's being established, the authentication is all encrypted. So let's scroll down. Oops, wrong panel. There we go. And we're looking in here underneath protocol for OpenVPN. So we'll scan down. Now the other thing that should jump out at you about these packets is these are not queries being made by my machine. These are just DNS queries being made in general by other people at the coffee shop. So just because you connect to some public Wi-Fi that has a password, even though it has a password to connect to it, that your traffic is not secure. Anybody else in the coffee shop can see your network traffic too. This is why people use things like a VPN, so that their traffic is encrypted, then sent to the VPN provider, and then goes out to the internet. So basically your traffic at the coffee shop can't be sniffed. Okay, so there's an OpenVPN packet. And this is where we're just starting our VPN connection. So let's start off by looking at the IP header. I'm going to show you another cool feature of Wireshark. So this IP address is the firewall at home. This is my IP address on the Wi-Fi interface at the coffee shop. So what we can do is select that, right click on it and say apply filter selected. So now we're looking at every packet where this IP address is the destination IP. What we really want to see though is every packet where that IP is the source or the destination. So I'm going to put that in parentheses and then say or, 2 vertical bars is an or, open paren, IP.source is equal to, and you got to have 2 equal signs there, 10.0.44.205. And notice it turns back green as soon as I have the syntax correct. So then that lets me know that I know that search query is syntactically correct. Okay, so here's all of the packets to and from my laptop over the Wi-Fi interface while I was running tcpdump. And so you can see I started doing OpenVPN. There's also a DNS query in here. And if we expand that part of the packet, here you can see that first query that I did for squid.bystec.com. And if we look here, we can see that here's where we're getting a reply. And if we expand the... Is that where I'm doing the reply, or is that where I'm getting the query? Okay, and the response here is basically telling me it doesn't know, but here's the authoritative response. Here's the authoritative DNS server to try to get a response. And there should be a section for the answer. Oh, here it is. Query response, no such name. So basically, I did the query, and because I didn't have the VPN session going, it couldn't resolve that host name. So that's what we expected to see. Now let's filter by something else. Let's say we want to filter only OpenVPN traffic. So we'll say apply as filter selected. So we filter out all the DNS stuff. Now we're looking at only the OpenVPN traffic. We'll select the first packet. Now what I'm looking for in here is anything in here human readable? Because hopefully not, because this is when I'm establishing my VPN connection and I want all that authentication to be encrypted. And it's looking good. I'm not seeing anything human readable in here. Pretty cool, huh? All right, let's look at the next packet capture. Now this one, if you remember, was still capturing off of the Wi-Fi interface, but after we connected to the VPN. So what I'm looking for here is the traffic that I generated over the VPN to my home network, is that encrypted? So that'll be an easy one to test. So again, I'm going to set a search filter so we can look at just my laptop's traffic, and here you can see that the traffic is coming from, it's all OpenVPN traffic, which is good, and we would just want to see that it's all encrypted. And looking at that bottom panel, I can see all of it is encrypted. If you remember, I did a DNS query while I was sniffing the wireless interface but connected to the VPN. And the DNS query, of course, went over the VPN to my DNS server, and it resolved correctly. It gave me back an IP. So this is good. This is all encrypted. All right, let's look at the last packet capture. Now, if you remember, this one was started on the VPN tunnel after we opened the VPN tunnel. So this would be showing only traffic that went over the VPN tunnel before it got encrypted and sent out the wireless interface. So for instance, you can see we have a DNS query and a response. That was the first thing we did. So we've already seen the DNS queries. Here's what the response would look like. You can see in this case there's an answer section that we can expand, and sure enough there's the answer to the DNS query. And we also connected to the mail server, as I recall. So we could look at this. You can see this is the start of a TCP session. The SYN, ACK, and SYNACK sequence that you've probably heard about. And then finally it realizes this is an SMTP connection, and you can see this is where this is the welcome statement coming back from the mail server. Now we've already seen how you could select the protocol and say apply as filter, select it, and see all SMTP traffic. But where things get messy is, let's say it's a mail server that has lots of people connecting to it at the same time, or sending an email all at the same time. And you want to pick out just a single SMTP transaction between one client and one server. How do you filter out stuff so it's not all intermixed? So we're just looking at SMTP packets. There might be 3 different IPs all talking to this server sending email at once. So it turns out there's an easy way to do that in Wireshark 2. You can select any one of the SMTP packets for a specific transaction, and then you can right click on it, and there's this really cool option, follow TCP stream. And it will pick out all the individual packets that make up that one TCP session and display, if it's readable, it may not always be human readable, but display that TCP session. So the blue will be coming from the server in this case, and the red will be coming from the client. That's an extremely useful feature in Wireshark. I use that one a lot especially when I'm sniffing traffic for an entire VLAN, and then I'm picking out web traffic, for instance, and then I want to look at just one transaction, just one TCP session. So this is by no means an exhaustive demonstration of Wireshark and all of its features, not in any stretch of the imagination. There's just a million and one things you can do with it, and hundreds of different ways you can do different things. But I encourage you to start capturing some traffic on your own machine and opening it up with Wireshark and just taking a look at the network traffic to see what it looks like. If you've always wondered what the transactions between a mail client and a server looks like, capture it, open it up, and look at it. And I hope this is useful to somebody.